So now let's move on to what are called the SUVAT equations. So far our examples have been simple. We do have formulas for more complex analysis, however. So the symbols are the same across all. So T is time, S is displacement, U is initial velocity, V is instantaneous velocity, A is acceleration. That's what I meant by U and V are both used for velocity. U is the initial velocity, that's the thing to note here. So that's how fast it's going initially. So if an object's dropped from rest, that means that the initial velocity is 0, or if something's shot out of a car or something, the car is initially moving at 10 meters per second. If the object's shot out from it, then its initial velocity is 10 meters per second because that object is moving with the car. So the SUVAT equations are on the right, and they show you what you need to know. I believe they're already on your formula sheet, but just be comfortable with using them. It's just get used to using them because they turn up quite a lot, especially the first, the first 4, I guess. Or first 3. I think the 4th and 5th one are less commonly used. I believe this should be a U. Sometimes it's a negative. But the 5th one is just a version of the second one. So don't stress out too much about that one. The 4th one is about using average velocity in order to figure this out. In order to figure out displacement. Again, not that commonly used, but the first 3 are the most commonly used ones. Here's an example. A car is initially stationary, then accelerates at 5 meters per second squared for 10 seconds. What's its final velocity? Now, this isn't actually too hard because we know what 5 meters per second squared means. It means 5 meters per second. So after 1 second, it's traveling 5 meters per second. After 2 seconds, it's traveling 10 meters per second. After 3 seconds, it's traveling 15 meters per second, and so on. So we know it's traveling 150 meters per second after 10 seconds, which is very fast. Sorry, it's traveling 50 meters per second after 10 seconds, which is, still fast. But the final velocity, but we can use one of these equations to do that. So in this case, we're asked for the final velocity. So the 2 equations that should stand out to you should be equations 1 and 3 because they both give us the final velocity. In this case, they've given us the acceleration and the time it accelerates for. So we're given A and T. So in the 3rd equation, we're not given S. Right? If you can't go back here, it's not given how far it goes. So maybe you want to skip it for now. But we are given how long it takes, and we're actually also given the initial velocity. Although it's not given as a number, it does say the car is initially stationary, so U is 0. So we get V equals U plus AT. Let's use that for part A. Part A, V equals to U plus AT, where U is 0 in this case, so we can say 0. Maybe I'll write that out and hit needle. V equals to U plus AT. U is 0 because that's the initial velocity. A is 5 meters per second because that's the acceleration. And T is 10 seconds, so it's going to be 50 meters per second. The final velocity of the object, or of the car in this case, is 50 meters per second. In this case, they haven't given a specific direction, so maybe we'll leave the direction out for now. But if it's going forwards, then forwards, or if it's going north, it's north, and whatnot. The displacement from the starting position, how do we figure that out? Well, for that, we're going to have to come back here and use one of these equations. So out of the first 3 equations, the first equation we've already used, and it doesn't really have the displacement in it, so it's not super useful for us for the part B. Displacement equals ut plus half at squared. That's a potential option, and so is 3. V squared equals u squared plus 2as. If we wanted to use 3, we're going to have to rearrange for s to make that the subject, which is very common. It turns up a lot, so that is a potential option. But I think for part 2, for part B, we can actually use part 2. We can say ut plus half at squared. So displacement, and just a side note, you can actually derive these equations using calculus just by the definition of velocity, just by the definition of acceleration, velocity, and displacement, and assuming that the acceleration is constant. And that's also a big note for these questions. Acceleration has to be constant for these equations to apply, otherwise you're going to have to use calculus, which the syllabus doesn't require, but in cases where the acceleration is not constant, these equations don't actually apply. So displacement equals ut, so u is 0 plus half, maybe I'll write the equation. So for part B, displacement equals to ut plus half at squared. u was the initial velocity, so that's 0, plus 1/2 times a is the acceleration, so 5, times t squared, so 10 squared. Right? So we get 0.5 times 5 times 10 squared, so that's 250 meters. So the displacement is 250 meters. And so we're done. Again, direction is not given or specified in the question, so it's hard for us to specify it. But if it was, then you would say 250 meters north, 250 meters east, or 258 meters 30 degrees from the horizontal, whatnot. This is something that takes a lot of practice to get the hang of in terms of using the SUVAT equations, so I'd encourage you to go home, look up some videos with more examples, and tackle them yourselves. As you work on it more, you'll get more comfortable, but my aim here today is to introduce you to the idea of kinematic analysis. Now, these three formula are on your formula sheet, which you can find here, and that's what will be given to you in your actual HSC exam, so this link's here for you guys. I believe, again, you can download these slides from from down below, but yeah, these three formulas are actually given to you in the physics HSC, but I highly recommend being familiar enough so that you can just use them straight away. Okay, so over the course of physics, you will learn about everything on it, on the formula sheet, so you want to know it really well. Print it out and put it with your physics book, or have it at hand whenever you study physics, because many times you can use the formulas directly off it. Yeah. So yeah, know your formula sheet.